Here's a review on factoring with special products. The first one we're going to look at is the difference between squares. There are three things that we're going to be looking for. It must be a binomial, which means it has two terms. It must have a minus sign, and it must have two perfect squares. So taking a look at x squared minus 25. It is a binomial. It has two terms, x squared and 25. It has a minus sign, and it has two perfect squares. X squared is a perfect square because we can take the square root of it and get x, and we can take the square root of 25 and get 5. Now this is where we have to remember, when we have the difference between perfect squares, we're going to have different signs. X plus 5 times x minus 5, or you can write x minus 5, x plus 5. So you might be wondering, why do we have to have those opposite signs? Well, if we were to FOIL this, I'm going to get rid of this here. X times x is x squared. X times negative 5 is negative 5x. 5 times x is plus 5x. 5 times negative 5 is negative 25. These two terms here, negative 5x plus 5x, cancels out. We end up with no x's, which is why we have x squared minus 25. So a shortcut here is just going to be the answer of x plus 5, x minus 5. That's the factored form. Now, you may be wondering, can I still do the x with this? Yes, you can. So, let's think about it this way. This problem is x squared plus 0x minus 25. So when we do our x, what numbers multiply to get me to negative 25, that add to get to 0, that middle term? Well, you have 5 and negative 5. 5 times negative 5 is negative 25, and 5 plus negative 5 is 0. So that's where your x plus 5, x minus 5 comes in. So if you're still not comfortable with just knowing the shortcut, you can always go back to doing the x. Two more problems to review before we start to look at perfect square trinomials. X squared minus 9. We have a perfect square here, and we have a perfect square there. So go ahead and put down your parentheses, put your x's down, plus 3, minus 3. Here we have a perfect square with a perfect square and another one. Square root of 4 is 2. Square root of x squared is x. Square root of 49 is 7. Be careful with these types of problems. We have a binomial because we have two terms. We have two perfect squares, but we have a plus sign. It is not a perfect difference between squares, so you can't do anything with it. Also be careful with something like this. Yes, we have our perfect square, we have our minus sign, but this is not a perfect square. Remember, it has to be a number that can be multiplied by itself. The only numbers that are going to go into 8 would be 8 and 1 and 4 and 2. So just be careful. That's another one. So get ready to do some perfect square trinomials next. Here are the perfect square trinomials. So the key here, trinomials. You will have three terms. So take a look at our problem here. X squared plus 6x plus 9. We have three terms. So let's identify your A and C values. We're going to work with this little template here, this little legend, to see if this is a perfect square trinomial. So the square root of a is 1x, or x. The square root of c, here's our a, here's our c, is 3. So now we have 2 times 1x times 3. And that equals 6x. So, is 6x that b term? Yes. Therefore, x plus 3, or x plus 3 quantity squared is the factored form for x squared plus 6x plus 9. And we can FOIL it just to show x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9, x squared plus 6x plus 9. Let's take a look at another practice problem. Here's another example. So we have 4x squared plus 16x plus 6. So why don't we take the square root of a, which is 2x, the square root of c, which is 4, and then we need to double that, so we have 2 times 2x times 4, which is 16x. And is that the middle term? Yes. So we have 2x plus 4 quantity squared. Here's one last problem. 4x squared minus 12x plus 9. So the square root of your a term is 2x. The square root of your c term is 3. So we have 2 times 2x times 3, which gives you 12x. The one thing you have to look at here is that this is a negative. So you're going to have 2x minus 3 times 2x minus 3. Watch what happens when we FOIL it. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is positive 9. So you'll notice that these here will give you that middle term of that negative 12x. So your answer is 2x minus 3 quantity squared. So just to look at this one last problem here. Square root of a is x. The square root of c is 4. So you have 2 times x times 4, which is going to give you 8x. 8x is not what's here. So this is not a perfect square trinomial. You might have to go ahead and look at 16 and 6 and say, are there any numbers that you could multiply to get you to 16 that would add to get you to 6? 16 and 1 doesn't work, 2 and 8 doesn't work, 4 and 4 doesn't work. So this is done. You can't do anything more with this one. So just make sure you're very careful with identifying that middle term here and seeing if it matches. Just because you have 2 perfect squares on the a and the c does not mean it's a perfect square trinomial.